Okay students, so let's find out the electrostatic potential at a point due to an electric dipole. So this is the dipole, we all know contains of equal and opposite charges at some distance apart, and we know that dipole moment, it has direction from minus charge from the positive charge. Let point P be the point of observation. Now here we are not going to do any axial or equatorial line because electrostatic potential is a scalar quantity. So the direction does not matter here much, right? So dipole moment, the magnitude we already know is q into 2a. Let us now find out the two different electrostatic potentials from this point and from this point. The electrostatic potential at P due to A will be minus q upon 4 pi epsilon naught r1. This is the relation which we have just obtained from the electrostatic potential due to a point charge. So electrostatic potential due to this point charge at point P will be equal to plus q upon 4 pi epsilon naught R2, right? And then the total electrostatic potential will be sum of these two. So I'm just putting these values and it has come this way. Now further we need to see the geometry. If you see here, this is the direction of A and this is the direction of R, right? If I can just, because it is unlocalized vector, so A can be put here also. So A and R are making an angle theta with each other, right? So if we see this is R1, then from the triangle of vector relation, this plus this gives you R1, right? So R1 square can be written as, the magnitude can be written as R square plus A square plus 2AR cos theta, right? Similarly, R2 square can be written as R square plus A square minus 2AR cos theta, because in this case A and R2 combine together to give R. So R2 can be obtained by R minus A, or we can say that cos of 180 degree minus theta if their angle is like this, right? So now we may rewrite R1 square as R square common a square by r square plus 2a upon r cos theta. Now take this special case if a is very small as compared to r. So a square by r square can be neglected, right? So just neglect this. Therefore, this implies that r1 square can be written as r square into 1 plus 2a upon r cos theta. So in this case, I have not neglected 2a upon r because it is small but not to be neglected. Neglect a square by r square is to be neglected because it is going to be very small as compared to a upon r, right? Because when we do the squaring, it becomes further very small quantity. So a square upon r square I have neglected, so r1 square comes out to be like this, right? And if we have, but we need 1 upon r1, right? So r1 square is here, I can take r1 by square root both sides, and then I'll be taking the reciprocal. So r1 comes out to be r into 1 plus 2a upon r cos theta square root, right? But I need 1 upon r1, so it becomes 1 upon r, 1 plus 2a upon r cos theta raised to power minus 1 by 2. Similarly, you can get 1 upon r2 as 1 upon r, 1 minus 2a upon r cos theta raised to power minus 1 by 2. This relation I have obtained from R2, right? Similarly, as we have proceeded for R1, I can do for R2, only the difference will be that with 2AR cos theta, we are having the negative sign. So that will come up in this expression also, right? Now you have to put the value of 1 upon R2 and 1 upon R1 in this equation. We'll name it as equation number 1. So in this equation, because here we are finding the total potential. So I'm just putting the values. So I've just written these values, put those the values, and now I'm going to use the binomial theorem. Binomial theorem says that 1 plus y raised to power n is equals to 1 plus ny if y is very small as compared to 1. So we know here also 2a upon r into cos theta is very small as compared to 1. Similarly, 2a upon r cos theta is very small as compared to 1. So I can apply this formula here. This expression has been used widely in class 11th also. So V is equals to Q upon 4 pi epsilon naught. I guess R we can also take out. So now this becomes 1 minus 1 by 2 minus 1 by 2 into 2a upon R cos theta. Basically I have just taken this power as a multiple of the second term. So this power comes as a multiple of the second term. Minus 1 plus minus 1 upon 2 into 2a upon R cos theta. Now I'm just going to do some mathematics. I'm getting 1 plus this 2 and 2 cancels, this 2 and 2 cancels, 1 plus a upon r cos theta minus 1, this was minus, minus becomes plus, it becomes a upon r cos theta. So basically here these ones are going to cancel out, and the total final output which we are going to get here is Q upon 4 pi epsilon naught r into 2a cos theta upon r. So it can be written as Q into 2a we know is dipole moment. So you get P cos theta upon 4 pi epsilon naught r square. Right, now we know that V is a scalar quantity and P is a vector quantity. Now if I have to depict V in terms of P, which is a vector quantity, it has to be expressed in terms of the scalar product, right? So what I can do is I can write it like this upon 4 pi epsilon naught r square, because this is a unit vector. Unit vector is not having any magnitude, but the direction of this unit vector is this direction. So P and R are making angle theta with each other. So the unit vector is also in this direction, right? So if I take the dot product of vector P and unit vector R, it comes out to be P into 1 into cos theta. So this is P cos theta only. So this is the way we can express a scalar quantity as the dot product of two vector quantities. Now you can take the special cases here, which you have to do yourself. Special cases is when theta equals to 0 and when theta equals to 90 degree. Theta equals to 0 means axial line and theta equals to 90 degree means the equatorial line.